Okay, we are into the second session of the angle properties of circles. So um, I have to tell you the three angle properties of circles. Okay, for that you have to assume that all these eight circles over here, they all have the same radius. Okay, that means they're all equal circles over here. Okay, I have drawn some chords into these circles, and now I'm just going to use these circles and I'll draw some more lines here. Give me a minute. Okay, I have completed the diagrams. Now we have eight circles, and all these circles have um, the equal radius. I am using the points, the same points A, P, B, Q in all these eight circles because I have to discuss something over here. Okay, you can see that there is this chord in black, which is AB, that is dividing the circle into two segments. And in these first three circles, the upper segment is a minor segment and the lower segment is a major segment. And if you look at these last four diagrams, the upper segments, they are bigger than the lower segments, okay? And you can see that this upper segment has gone very big and we have a very small minor segment over here. In this fourth diagram, we have this AB bisecting the circle into two equal parts, okay? So uh, you have to tell me that if I just name this angle APB as X, okay, this is angle X here, and here is the angle Y, okay? So what is happening to the angle X if we look at this picture, this diagram carefully from the circle number 1 to the circle number 8? What is happening to these angles X and Y in it? Yes, Malaika, tell me. First of all, tell me, what do you notice in the value of this angle X if you look at this from diagram 1 to the diagram number 8? Yes? What do you observe? What is happening to the X? Mhm.
It's getting bigger.
Very good. It's getting bigger or smaller, angle X.
The angle is getting smaller.
Uh, The angle X, the angle APB is getting smaller. And what is happening to the angle Y?
It's getting bigger.
It's getting bigger, okay? Now, can you notice that uh, the bigger is the segment, the smaller is the angle on its circumference. Like if you look at the diagram 1, the lower segment is a very big, a major segment, but the angle Y is very small in it. But if you look at the last diagram where the lower segment is a very, very small segment, but you see angle Y is very big there. Okay. So can we make a rule here that if the bigger is the segment, the smaller is the angle in it, and the smaller is the segment, bigger is the angle in it? Yes.
Yes.
Yes. Okay. Now from this, uh, what would you say that if your chord is dividing the circle into two parts, so what would you tell us about these two values of, this is your X here and this is your Y? So what do you notice about them?
They are equal.
They are equal. Very good. Claps for you, Malaika. Very good. Because the segments are equal, so the angles are equal. Okay. Later, we will say that the angles in the, uh, I mean, same segment are equal. I'll just prove through this. Okay. Now, next, you see that in this fourth diagram where you're saying that this angle X and angle Y, they are equal. Uh, if you're going to again look at this first diagram and first to from the eighth circle, um, like in the first diagram, the angle X is an obtuse angle and the angle Y is an acute angle. Okay. And if we look at from the first to the second circle, uh, the angle x got bigger, sorry, angle x got smaller, and the angle y became bigger. If you look at from second to the third circle, angle x became further smaller and angle y became further bigger. Okay. And in the fourth diagram, like in the first three diagrams, angle x was obtuse and angle y was acute. But when you look at the situation in the fourth circle where both the segments are equal, then you can say that, okay, when the angles, I mean, the segments are equal, then it means the angles are equal. So they're both equal. So they are neither acute nor obtuse. They are both equal to right angle. They are both equal to right angle. Yes? Yes? Yes, Malaika? They are both
Yes.
equal to right angle, okay? So in all these 8 diagrams, we can say that x plus y is equal to 180 degrees. For example, from this first diagram to second diagram, if your angle x has gone down 5 degrees, okay, then the angle y has definitely gone up by 5 degrees. Okay, because their sum has to remain the same. Like if this was, let's say, if it was 160, and now if it is 155, and if it was 20, now it should be 25. Only then the sum remains as 180 degrees. Okay, so from here, we have the first property of the circle is that if you have a semicircle, the angle in a semicircle, like when we are going to talk about the angle properties, will be uh, we will only consider the angles which are being formed on the circumference over here. Okay, so the angle in a semicircle is a right angle. So that is the first property that you need to remember, that like if there is a diameter over here, okay, and it makes an angle on the circumference, this angle will always be a right angle. If I could draw a neat circle over here, okay, so you see that it is the first circle's properties, circle's angle properties, that the angle subtended, it is also known as the angle subtended by the diameter, is a right angle. Okay, so this angle over here is going to be a right angle. This is called, its shorter form is angle in the semicircle. Okay, or this is also called angle subtended by, subtended means made by, angle subtended by the diameter is a right angle. Okay, so this is the first angle property. We are basically dealing with the angle properties of the circle. Okay, now if I go back, so the next thing, um, if I, for example, if you allow me to draw, let's say I draw another line here, another angle over here. Okay, now uh, you have to be very alert, Malaika Bete. Suppose this is u. Okay, now what is x plus y? What is x plus y here?
180.
180. Okay. Stay with me. X plus y is 180. Now, suppose this this is no more here. This is not here. This is not here. Not here. Okay. Now, what is this u plus y? What is u plus y? Hmm? What is
Uh,
u plus y? Yes. What is u
mm,
plus y? Hmm?
9. Uh,
For example, if I change this angle's name as, if I call this as,
it should also be 180.
yeah, if I, for example, if I name this as A, so what would you say about this A plus Y here? That is 180, yes. And this U plus Y is also 180. Okay, now, stay very alert, Malaika Bete. Now, if I just draw this again here, and here I have the point P, and here is the angle X. Now, if X plus Y is 180 and U plus Y is 180, what would you say about the U and X? Yes,
They are equal.
they are equal. Very good, Malaika. So we are going to uh, go into the second property here that says that if inside a circle, like you have a circle, okay, and there is a chord, okay, here is a chord, okay, and then you have you have an angle here from this chord, okay, you have another angle here, let's say you have something like this, okay, you have one more angle here, let's say this is, I draw it in black here, this is like this, and this is like this, okay. So from this previously learned property, this is A, this is B, this is P, this is Q, this is R. So you see that all these three angles, let me call these angles A, angle B, and angle C. They're all in the same segment. They're above this line AB in the major segment, okay? So we can say that angle APB, angle AQB, angle ARB, they are all equal. And we say that these are the angles in the same segment. These are the angles in the same segment, okay? These are the angles in the same segment. So whenever you see the angles like this, for example, you have an angle here. Let's say there is an angle here, which is angle X. And there is another angle over here, which is Y. So that would mean the angles X and Y, they will also be equal to each other because they are in the same segment. Because if A plus X is 180, you look at this, A plus X, you know, this is 180, okay? What is B plus X? That is 180. And what would be A plus Y? That is also 180. What is B plus Y? That is also 180. So that means angles A, B, and C, they are all equal, and angle X and Y, they are also equal to each other. But the angles in the opposite segments, they add up to 180 degrees. Okay. Now, just one more thing from this diagram, from this, there is a third property of the circles. Uh, let me conclude this discussion, and inshallah in the next segment we'll talk about the cyclic quadrilateral. Okay, now Malaika, uh, we have here there is a chord here, okay, and there is an angle like this here, there is an angle like this here, okay, and then we have an angle in the minor segment, in the minor segment, okay? And this time we have the center as well. Okay, now suppose here is the center of this circle, okay? Now this is A, this is B, this is P, this is Q. Okay, now if this is the angle X over here, okay? This is the angle X, and this is the angle Y. So what is X plus Y? You know it well now. What is X plus Y?
180.
That is 180. Okay. Uh, now, If x plus y is 180, what should be 2x plus 2y equal to? Yeah. Yes, Malaka bete. What should be 2x plus 2y then? If x plus y is 180, then what should be 2x plus 2y?
Uh, 360.
Yeah, that should be 360. Okay. So this is going to be 360. Okay. What is this sum of these two angles over here? What is sum of these two angles here? Something this and something this. What is sum of these two angles here?
360.
This is 360. Yes. Okay. Now, which one is the bigger angle, the lower angle or the upper angle?
Upper.
Upper. Okay. Now, out of these x and y, which one is the bigger angle, x or y?
Y.
Y. Okay. So this is going to be, let me just erase this. Okay. Now, here it is 2y and here it is 2x. Okay. Now, this gives you the third property, the third angle property of the circles, that the angle at the center is twice the angle at the circumference. You see that? Here you have from this PQ. Look at this, sorry, AB. The angle APB is equal to x. Therefore, the angle AOB, that will be 2x, okay? So its shorter version is, you need to learn the shorter versions of all these properties because you have to write this as a reason. So you must know its shorter version. So we say that angle at the center is twice two angles at the circumference. Okay. Or you can say angle at the center is twice the, you can say twice the angle at the circumference. Okay. So if this angle is y over here, then this angle is going to be 2y. Now, sometimes the students get confused with this. Let me give you an example. And then later we shall discuss the questions from the past papers. Okay. Now, suppose here is the center. Okay. Uh, Now, you're given that this angle over here is, let's say this angle is 150. Okay. And you have to find this angle. Let's say this angle is X. Okay. This is A, O, B, C. Can you tell me what is the angle X? Hmm?
Uh,
Okay, now the very common mistake over here is the students say that, okay, if this is 150, so this is going to be 300. Now, does it look like a 300 degrees angle? Hmm?
no.
No. So this means this angle over here is going to be 300 and this angle X is going to be 160. Okay. There is one other reason for this. For example, if you let me draw a line over here like this and like this, okay? If this is 150 degrees, what is going to be this angle over here? If this is 150, so what is going to be this angle here? Oh, this was 60. Uh, I took a very bad example here. This is 150. Twice of 150 is 300. So this angle has to be 60. This does not look in any way 60 degrees. So this should be an angle of, let me take it as one, like 90, 20. This should be 130. This should be 130. This is 260. And now this is, yeah, this is a better example here. Okay, sorry for that. I just took a bad example here. Let me draw this again. Okay. This happens when you're just making the questions yourself. Okay. Now, I just assume that this angle over here is, now this is such a big angle. So let's take this angle. If I take this angle as maybe 140 degrees, so this angle will be 280, yes? And this angle
Mm.
over here will be 80 degrees. If this is 140, okay, then this angle over here will be just 40, because you see 40 plus 140 is 180, and what is the twice of 40? That is going to be 80. So angle at the center is twice the angle at the circumference. Okay, so if I just neat it up a bit, okay, so the things would get clear. Okay, so now, suppose if this angle is 100, the angle over here will be 50. If this is 50, this is going to be 130. This is 130. This angle is going to be 260. So we have discussed three properties over here. Angle at the center is twice the angle at the circumference. Then angles in the same segment, they are equal. An angle in the semicircle, that is a right angle. Okay, so angle in the semicircle is a right angle. Angles in the same segment, they are equal to each other. And then angle at the center is twice the angle at the circumference. If you just give me one more minute, I can uh, include the cyclic quadrilateral into it as well. Okay, just one more minute, and then you see this can be just introduced over here. Look at this. Can I say this A D B C as a, yes, like A D B C? Isn't it a quadrilateral? Yes.
Yeah.
Okay. So when you have a quadrilateral, um, in such a way that all the vertices are on the circumference, then it is called a cyclic quadrilateral. Okay, this is called a cyclic quadrilateral. Okay, so why it is cyclic? Because all its vertices are on the circumference. So its properties related to the circles are that in a cyclic quadrilateral, the opposite angles, they are always supplementary. The opposite angles, they are always supplementary. If you look at this diagram, in all these 8 circles, we have 8 quadrilaterals here as well. Like look at this APBQ. APBQ, these are all quadrilateral. Okay? So their opposite angles, they are adding up to 180 degrees. Okay, so you can write today's fourth property that a cyclic quadrilateral, or we can say that the opposite angles of a cyclic quadrilateral are supplementary. Okay, they are supplementary, they add up to 180 degrees. Okay, I'll continue from this, and in the next segment we'll talk about, we'll complete the cyclic quadrilateral, and we'll talk about the tangents on a circle, and then inshallah we'll go on to the questions from the past papers. Okay, thank you very much.